interested to maybe connect some of those regional offices to some of you all as well to see what they can do using the Open Sidewalk standard or using other technologies we've talked about. But I'm not part of those regional offices. I'm part of the global team. So we work on sort of international analysis, international policy, supporting sustainable and inclusive city transport. And I'm very excited about access. So we've been talking a lot about access today and yesterday. And access is kind of a slippery topic because we don't actually care about access itself. We care about what access lets us do. In Amartya Sen's words, the economists, it is kind of like money or education in that it is a general purpose means for having more freedom to lead the kinds of lives we have reason to value. Sort of, as Karen put it yesterday, to live our full lives. The kinds of lives we have reason to value. But it's not our place as city planners to try to predict or assume what people want. It's our place as planners to try to give people the options to do the kinds of things they might want to do, whatever those things are. And again, Karen asked yesterday, what do all people need to get to their destinations? It's our responsibility to answer that question. And in order to answer that question, we need a way of measuring people's ability to get to whatever they might happen to want to do.
Recording in progress.
We don't need to measure access to particular destinations that we might assume as some kind of overlord planner that people want to get to, or by particular modes that we assume people are going to want to drive and not take the bus. But we need to be able to measure access in general, however that might work for people. And I want to talk about disability as one contributing factor to access, but not the only contributing factor, right? Somebody earlier this morning had the example of, you know, Bill Gates, 90 years old, physically impaired in some way perhaps, but wealthy enough that he can get anywhere he wants by whatever mode he chooses, fleet of chauffeurs. And so a wealthier person, though they might have a disability, might have more overall ability to access destinations than a lower income person, although they are able-bodied, living in a very marginal fringe community on the outskirts of the city. So we want to measure access in general. How do we do that? Today I'm going to be talking about an approach to doing so that I call the connectome. I'll describe it in theory first. So I want you to think about, okay, this general idea of how can this be done? And then I'll show you a prototype that we've been working on for actually measuring this in access, and the example of congestion pricing in Washington, D.C. So why am I calling it the connectome? In neuroscience and in artificial intelligence, the connectome is the map of all of the axons and dendrites connecting all the neurons of the brain. So in city planning, let's understand the connectome as the map and the measurement of all of the ways people have of getting from their origin, whatever that is, to the destination, whatever that is. So, talking about access by different modes and what it is that we are trying to measure here. So I live by the Star in the Linear Heights neighborhood of Washington, D.C., and getting to different places in the city, it's more or less convenient to do so by different modes. So the red lines are bike lanes, the green lines are metro rail lines. So if I'm trying to get downtown, of course I'll walk to the metro station and hop on a train. That's the fastest way, the most convenient way for me to get downtown. If I'm trying to get to the Georgetown neighborhood here, the most convenient is to get on my bike and follow that red bike lane down. But if I'm trying to get maybe over toward the northwest area, I'll have to walk or call an Uber, or something like that. So for each possible destination in the city or in the whole metro area, it takes a certain amount of time for me to get there by whatever the most convenient mode is. So if we wanted to measure my overall access to destinations, we could just measure all of those times, right? And take like the average That's close. That's not quite exactly what we're going to do, though, because different times to get to different places have different measures of value. So this is a pretty technical point, so if you don't feel like thinking about math, you can tune this one out. But I wanted to bring it up because a destination, so this is based on empirical research from the State Smart Transportation Initiative in Wisconsin, I believe. And a destination nearby is more valuable than one farther away, but a destination twice as far away is more than half as valuable as one a certain distance away, right? A cafe half an hour away is more than half as valuable as a cafe 15 minutes away, is more than half as valuable as a cafe 7.5 minutes away. Happy to talk more about this graph later. I know it can be a little controversial or difficult to understand, but I just wanted to at least mention it. So going back to this map, though, I am not the only person living in my neighborhood, and not everybody living in my neighborhood has the same characteristics as me. A wealthier person might have a different sort of access map because they can more easily afford to call a taxi. Someone with a physical disability might have a different access map because they don't move as fast on sidewalks, or because they can't use certain sidewalks because of obstructions or lack of curb cuts. And, you know, in the real world, every individual has a different set of abilities or capabilities to use different modes. And so in theory, if we had the most powerful supercomputer and all of the perfect data, what we'd want to do is iterate through each individual person in the entire metro area and map their ability to get to each individual possible destination by each mode, pick which one's the most convenient, figure out how much time it takes for them to get there, put that on the graph in the last slide, and take some measurement of the value of the cumulative value of their abilities to get to all their destinations, all possible destinations, and then take the sum of that for every person in the metro area. And then you'll get a number. You will get a single number, which I will refer to as the measurement of the connectome of the entire city. And that measures everybody's ability to get everywhere. And then the thing here that I'm most excited about is you could plug in a hypothetical change to the transport system. A new light rail line, a single fixed curb cut, a network of bicycle lanes, a new highway, reduced speed limits, whatever you wanted. And you could see how that possible change to the system would affect the overall connectome measurement. And you can start getting to the point of cost-benefit analysis and measuring sort of connectome points per dollar spent, and use that to prioritize investments. Of course, that is all in theory. So what about the practice? Before I get into the practice, though, I'd like to pause and take maybe one or two questions if anyone has any burning questions about that theory, if anyone didn't understand something there. Great, all the better. So that's the theory, what's the practice? So we've started building a prototype software tool. We're using R5 through the R5Pi library to do the routing, and a custom Python script to do the post-processing, using GTFS data from Mobility Data's database, and OpenStreetMap for the street, bike, and pedestrian networks, and US Census at the census tract level for population, income, and car ownership. Right now, we're able to process walking, all modes of public transit, bicycling for people at different levels of comfort with different levels of traffic stress, and driving, including traffic and parking, or at least rough approximations of those. And we take into account both the time and the money cost for an overall convenience factor. We don't convert, we don't convert time to money, we convert money to time. So we value everyone's time equally, which means we value wealthy people's money less, right? Rather than doing it the opposite way. Important things that we are still missing in this prototype include ride-hailing, shared bikes and shared scooters, e-bikes, including privately owned ones, demand responsive transit, handicap or access for people with disabilities in general, and that includes all of the open sidewalks sort of details that we've been talking about, all of these details we've been talking about all weekend in terms of ability to get over bumps or use certain pedestrian facilities. It's important to note that that also applies to a lot of people who aren't using wheelchairs, right? People who might have strollers, people who are just more tired and don't want to walk on a gravel path instead of a smooth sidewalk. And of course, there's lots of other things we're missing as well. People, you know, people prefer to spend time sitting on a bus than spend time waiting at an uncomfortable bus shelter. I would like to include this in the full model, but for now, we've got a basic prototype that works but isn't as detailed as I would like. So let's use that prototype to look at Washington, D.C. So this map is only looking at origins in D.C., but does include destinations for, I think, going out about 5 or 10 kilometers into the suburbs. Sorry I didn't put the units on this map. That is an unforgivable sin from a GIS perspective, but you know, darker colors means more access, and it basically correlates with car ownership and centrality. So obviously people living in the city center have high levels of access, but also people living in the northwestern part of the city, which is wealthier and has higher levels of car ownership, also have higher general access to destinations. The destinations I'm considering here are taken from streetlight data also. And we can do some statistical summaries here. If it goes to the next slide, I can show you those. Huh. You're seeing it. That's funny. Okay, great. Well, oh, it went way too far forward. Sorry about that. Oh, you're getting all these spoilers. Great. All right. Okay. This is what you should be seeing. So, we can see the overall value per person and sort of connection units per person. That's kind of a meaningless number. It's only meaningful relative to other numbers measuring the same geographic area. This is the existing conditions. This is what DC is currently like, so there's no change in value relative to existing conditions. And you can see the breakdown of where that access value comes from. So about 2/3 from driving, about 1/5 from transit, and the rest from walking and bicycling. I think it's slightly overestimating bicycling and underestimating walking. That's partly because of the relatively large analysis areas I'm using. Does this make sense as a measurement to everyone? Any questions? Anything unclear? Yes, Elizabeth.
I probably should have asked this when you were explaining the metric, but I'm wondering if you could explain. There's 2 clarifications I'm curious about. One is in the cumulative sum of all the access connections per person. Is that for the existing population, so weighted by like the current census attributes of people who are low income or who have low access to car ownership in each like locale? So if we were to, as a hypothetical, have a low income development in the northwest part of DC, that would they would experience potentially lower access than what is currently shown on the map. And the map is showing, I'm saying things, and you should just correct me when I'm wrong. The map is showing the cumulative for everybody that is currently live there across, that is segmented and calculated based on the segmentation of their.
Yes. So I believe what this map is actually showing is the average. I should have put the numbers on it again.
Okay.
The unforgivable sin of no legend in map, but it is showing, I think, the average quantity of access or value of access capability. I'm still kind of looking for language for these things, and it should have a unit too, right?
That's the hardest thing in accessibility calculations.
Yeah.
What are you actually measuring?
So, and actually this does have kind of a comprehensible unit, at least sort of, which is, so one access unit is the value that someone derives from having a single destination in general, 1 minute away from them.
Okay.
Um,
Access minutes.
yeah, access
Connection
utils
minutes.
maybe.
Sort of. So, but this is the average, so it's not weighted by population, I guess would be the other thing, or area.
Right, this is the,
Okay.
I mean, census tracts all have about the same population, right? So it's pretty similar to a map of overall access value in each census tract, but it is per person, and it's
Based on where they live.
based on the way they live,
Okay.
yeah.
And then the
and
other
it's the
question.
average within each tract, right?
Got it. And then the other question, when you flip to the table, is about the value of each mode. Could you discuss a little more about how that,
Yeah,
how you're
so
getting that? I think I'm a
maybe
little
it's
confused.
easiest to think of it for an individual person, right? So going back to where I live in Linear Heights, right? A lot of the closest destinations to me, I walk to. This is relatively few destinations, but they're very low amounts of time, and so the value of the value that I derive from my access to those destinations is associated with walking, right? And it's a relatively large amount of value from a relatively small amount of destinations. Whereas there are many destinations far out in the suburbs that I can best access by driving, and that takes a while or has a high impedance because Ubers are expensive. And so I don't derive very much value from each individual one of those, but because there are a lot of them, I derive more value.
So in
from
the,
that.
I'm just trying to make sure I understand. So in the example of, like you're walking 5 minutes away to a store or something, to a
Yeah.
grocery store, but you could also drive there. Would you be calculating both the access via walk and the access to car, or are you taking the best of? So are you
I'm taking the best of.
Got it. Okay.
Yes.
I understand
I
that.
should have made that more clear. Right. I'm
And
taking
best of based on your like specific like based on if you're low income.
based on sort of the overall hassle factor.
Got it.
Right. So for
the utility, so to speak.
someone who's higher income, the $2 to get on the bus doesn't really matter very much, so they'll take the bus. Someone who's lower income, living in the same building and going to the same place as a higher income person, might choose to walk, even though it's 5 minutes longer, because they want to save the $2.
Got it. So I think it's essentially like a log sum, except you're taking a best of instead of like a weighted average. Okay.
Yeah, and I've
cool.
thought about doing the log sum
Yeah.
instead.
So I think I understand now. Thank you for your.
Hi, so there's a question from Zoomland. Kim, do you want to unmute or would you like me to ask your question?
Yeah, this is really interesting. And I'm curious, what is the scalability or applicability to locations across the US?
I mean, the code, you can plug in the data from any metro area, any geographical analysis area you want and run it. It doesn't really take any specific data requirements for any specific cities at this point. Annette?
So what do you do with missing data? So what do you do with missing data? Because you mentioned grabbing from OSM, the sidewalk infrastructure and things like that.
Yeah, I mean, so again, this is a very rough prototype for now in doing pedestrian routing. I'm just assuming that anyone can walk at the same speed on any road or street, which is obviously wrong, but I think is better than excluding walking as a mode entirely. But that's one of my highest priority things to fix at this point. If a city doesn't have GTFS, you can't do this. If a city has GTFS for its primary bus and rail provider, but doesn't have GTFS for maybe one of its suburban counties, maybe you can still do it and your results are going to be a little off. I think you have to make a judgment call as to whether you have enough data to do it, which I think for most cities you do. And one thing I like about this approach too is that the higher resolution data you have, the better your results are, and the more you'll be able to assess really detailed interventions. But you can do a pretty rough assessment with very low data requirements. I'm going to keep moving and look at some alternative scenarios for DC now, and then we'll have a little more time for questions at the end. So this was the sort of existing conditions in DC. Let's look at, yeah, this is really slow for some reason. All right, so let's look at the impacts of possible congestion pricing. If we put in the kind of gray hashed area, cordon, so you had to pay $5 to drive your car into this zone in or out. What will that do to people's access to destinations overall? The answer is reduce it, right? It will, obviously this will have no effect on people who ride transit. It will have a negative effect on people who drive car, or people who own cars, I should say, rather than people who ride transit. There's no such thing as people who ride transit. There's people for whom transit is the most effective way of getting places. So this will reduce access for people who own cars, and it will reduce it from between, you know, a couple of percent up to negative, I think, 30% in the most affected areas within the zone. And, you know, then we can look at how much. And overall, for people in DC, it reduces access by 5%, with a slightly higher effect on low-income people, because even though lower-income people are less likely to own cars, they are also, the lower-income people who do own cars are more negatively affected by the $5 toll. It is harder for them to pay it. It represents more of an imposition. But then, it just so happens that the amount of money that congestion pricing would raise is just about the same that it would take to make the bus free for everyone in DC. So let's look at what happens if we put the free bus in. And now we can say, here's the impacts of access, the impacts on access in different neighborhoods. It goes up in some places, it still goes down, probably goes a little less down in others. You know, the wealthy northwestern neighborhoods I pointed out earlier still have the worst, still have a negative effect because they're the most car dependent. And we can look at the sort of statistical summary of the impacts of these two policies combined. And we see that overall, the combination of congestion pricing and free buses, access still does go down. It goes down by 2% instead of 5%. That's not that surprising. DC is a relatively transit-oriented city by American standards, but it's still by American standards. But even if access is going down overall, access is going up now for lower income people. And there's a substantial reduction in the percent of overall access value that comes from cars, and a substantial increase in the percent that comes from transit. So if you're a planner, now maybe you have to make the decision. Is it worth it for us to have this pair of policies that will make things a little bit worse for people overall, reduce access a little bit overall, but increase access for the least privileged, the people with the lowest incomes? Especially considering that it will, you know, help us meet our sustainability goals, reduce emissions, local air pollutants, and greenhouse gases. And sorry, is it worth it to make that trade-off? And what other policies can we consider? What other interventions could we model that might even flip it to the other side and have an increase in access to destinations overall? So this is the prototype, the functional prototype of a very, I think, ambitious theory. And the reason I'm sharing this with you is, first, to get your feedback. Do you think this makes sense? Do you think this is something that you could see yourselves using as planners, as advocates? And then, how can I work with you? How can we collaborate? How can we, you know, most appealingly plug open sidewalks into this? But then, how else can we improve it and test it and get it to be used in your cities? And try and make cities better for everyone. So that's all my slides. If there are more questions.
Just one comment. This is Steve Yaffe. The bike network in DC is a lot better than where I live now in Charlotte, where there's no connectivity between greenways. There's little investment in bike lanes. And that's, some cities are better than others. Let's put it that way. So that may vary that one category of bike access quite a bit.
Yeah, absolutely. But I'd be interested to do the cost-benefit analysis of how much access you might get by building a bicycle network in Charlotte.
Let's talk offline. Anat
do
has
it.
my email. I'm with Sustain Charlotte, CTR, Community Charlotte Regional Transportation Coalition, and we're all for it.
Yes.
I,
Oh, sorry. Go ahead.
so I'm Doreen Cornwell again. I think the point about connectivity of different kinds of networks is actually an interesting thing to think about. I'm not quite understanding so I don't drive. It doesn't matter whether I'm in Northwest Seattle, Northwest DC, which I actually did spend time in DC, and so I know a little bit about it, or, Southeast DC or someplace in Virginia. I don't drive. And I don't know how to we talked earlier about how to find people with disabilities or people who don't drive, but I think I might just not be understanding what assumptions you're making about roads and buses and what's the thing I'm looking for? Access to cars or proclivity to ride buses, because I don't drive, so like my number of bus segments in a day is going to be way higher than people who mostly drive and occasionally take the bus, or whatever people's driving commute patterns are versus their do stuff at close to home. So I think I'm just not understanding it, but there's also a trip pattern issue where, there's trip chaining. There's some people who will go out to and from work, and then there's a set of circumstances where you might go to work and drop the kid off at daycare, pick the kid up, do some shopping. I don't know. I think I'm still a little bit not understanding your model, but I'm also trying to figure out how to put those things into it.
Yes, thank you. I probably wasn't very clear. So it's true that more people in Northwest DC own cars than people in Central or Southeast. But not everyone in Northwest owns a car. And from the census data, do have those statistics about, maybe 20% of people in those Northwestern areas still don't have cars. And so those people, for them, driving is off the table. I'm only looking at the possibility of them taking the bus or walking or riding a bike. Does that answer your question? Yes.
Hi, this is Kim online. I would love to connect with you and talk about accessibility testing. My company does a lot of this all over the country for bike ped plans, and looking at better methods for accessibility for BCA testing is one of the things that we're working with Portland State University on right now, and this would be a really potentially interesting tool.
Yeah, I'd love to connect, Kim. Thank you.
Hi, I just wanted to share kind of a identity question that I have wrestled with myself, and that is the question of, am I a pedestrian? And I actually don't know. So for those who may not have line of sight to the speaker, I am a wheelchair user. And so, you know, in my natural state, unassisted by a vehicle, am I a pedestrian? It's not accurate to say that I'm walking, and I'm not just being a smarty pants when I say that, but I had to consider what the state of my wheelchair is in. With return to work, for example, I learned that I needed to replace my wheelchair batteries because it had been about 2 years since they had been replaced, and having a change in my pattern of activity, I learned, oh, I need to replace this item in order to maximize my access to work and other activity. So I've often wondered, do I get to use a bike lane? Sometimes the bike lanes are in better condition than the sidewalk. If there is bad weather and it snowed in Seattle and we don't know how to shovel sidewalks, can I go in the road? Is that a good idea? You know, so these are the sorts of things that I wonder, can a model like this capture? Do we need to unpack the ideas that are trying to be described by walking in this model? And so there's not really a question in that. It was just more like, here is a conundrum that I want to share for the sake of moving this work forward. And I don't know what I am in this model. So am I a pedestrian? That's probably the best definition that we have so far, but does it really support what we're trying to measure in this model? So thank you.
Yeah, it's a very hard question. And I think the answer to your question is ultimately like, no, the model is never going to be able to capture this perfectly. But we can do better, and we can keep trying to do better, and we can keep trying to take more and more into account. Annette pointed out yesterday the difficulty of segmenting population by, ability to use different facilities. Not all manual wheelchair users are the same. Not all powered wheelchair users are the same. And my model does rely on some amount of segmentation. So it's never going to be perfect.
But yes, you are a pedestrian. You're just a pedestrian who rolls.
This is really cool achievement to be able to have come up with a way to calculate this with data that's available everywhere. Like, this is the holy grail in many, many places, because, for so many reasons. I have a few questions just about the calculations and how it impacts maybe the policy decisions that might be made as a part of them. One of them I sort of alluded to before, which is about calculating it based on existing land use patterns and not about maybe people who could live there in the future, and whether or not we're self-perpetuating existing land use patterns by doing that. And so that's just sort of a question, and being either transparent about the fact that that is one of the things that we're doing as part of this calculation, or maybe adjusting that and sort of considering all segments from all locations and looking at how all segments would be impacted. So looking at basically different maps for different segments of population. And then there's a question about, do we even need to look at how access for, we could call like highly, I don't know how to phrase this, but high income, high auto ownership people, do we need to worry about their access? And when we calculate and I just worry about putting up a table where we're saying, like, oh, we're reducing access through this, and that even making that a question in policy circles about whether or not it's okay to have that trade-off, and whether or not we should instead of, another way to think of this is like, should we be instead looking at a sufficiency metric as opposed to an average metric? So what is by using the average, you're leaving out the access, the perceived access potentially as calculated for the people with the lowest amount. You could have a really long left-hand tail of access, and we should worry about those people the most. And we should be designing our systems for those people the most. And we need to have so I'm curious about maybe changing this to a minimum sufficiency as opposed to an average. And then I have a few questions, which is, not questions, just like other noodles, which is like, I really liked how the table where you showed like the relative importance of the different modes. And I think that could be used to look at lots of different things. I'd be curious to look at it on a map. I'd be curious to look at it based on population segments. And I think that I haven't fully thought through, but it seems to me like that concept could be really useful in understanding where are these really critical, and like where are these providing critical access, and making sure that we maintain the heck out of those places where those modes are providing critical access, and that could be really useful to people maintaining the network. And then I just have a question about you used US data, and you get to work all over the world, which I'm kind of jealous of. I'm just curious about the availability of this sort of data all around the world, and if you've seen really great examples of that would be able to enhance this metric, or just what the status is of that. So that was a lot because there was so much in your presentation to unpack, and I really appreciated it. Thank you.
Thank you, Elizabeth. So I counted 4 questions there. The first about actual versus possible population distribution. The second about why use the average as a key metric, and why even measure access for high-income people who own cars and are able-bodied. The third being the possible use of maps of the kind of contribution of modes to access to help allocate funding spatially, and the fourth being data availability around the world. I wish I could ignore the first one, but I'll try to answer it last. I don't have a good answer to it. So data availability around the world. GTFS is increasingly being published, especially in Latin America. Although, I wish cities and the World Bank would start making sure to include in their procurement that the data had to be published publicly instead of just being held by whoever collected it. Hopefully we'll get that message across to them. The European Commission has a very high resolution population density data set called the Global Human Settlement Layer. If you're a data geek and you don't know about this thing, it's incredible. Check it out. It's like 250-meter resolution. It's great. And between those two and OSM, we can do this wherever we want. We don't have income. That is the trick. Is income. Maps of mode distribution, yeah, absolutely. That can be done using the data I have. Give me like 20 minutes with QGIS after this, and I can show you some. Why use the average? This is a really good question. I fully agree with you that other indicators might be just as useful. You could imagine doing a Gini coefficient of access. You can imagine looking at specifically what I've tried to do here, look at access for lower income groups and use that as your metric. But so I'm not wedded to average as the key metric, but I am pretty committed to the idea of including measurements of access for people who own cars, because what we want is, so most of you know more about how transportation projects are funded in the United States than I do. It's not my expertise at all. But my impression is that often agencies allocate a certain amount of money to transit, a certain amount to walking and cycling, and then 90% to cars, right? And if we can show that all of this should actually be in the same pile, and we can increase access the most with transit and walking and cycling projects, we need to be able to compare apples to apples, right? We need to be able to show that a transit project provides more general access than a highway widening does per dollar. And as for your fourth question, Anna, you've got a question. No. So actual versus possible population distribution, it's a really tough one. It is true that people in certain neighborhoods have more car ownership and higher incomes than other neighborhoods, and we don't want to. I think it's better for us to spend our money increasing bus service in lower income neighborhoods. They need it more. But of course, there are also lower income people living in Northwest DC, and they deserve good bus access too. And you could imagine over the course of decades, income levels in different neighborhoods change, and we shouldn't necessarily build a heavy rail metro system based on current income distributions. So that is a thorny question, but I also think that it's important to look at current distributions.
I just worried that policy increases segregation.
Yes, a valid concern. It's definitely a trade-off. Yeah.
So one quick comment on this subject of access for drivers, and I was noodling on this as well, and it's a really good question, Elizabeth, but one thing that came up to me in seeing your results, Taylor, was just like, we'll have these public meetings, and because of access, 20 people who will show up and complain about, oh, you're taking away parking, or you're taking away, a lane, or you're not putting a lane there. Fewer people will show up to say you're not putting a bus there, or the bus system has been cut because of access, because the folk who are riding the bus are not able to access that public meeting or have the time and resources for it. And what your numbers showed is, like, quantitatively, sure, there may be 90% of people in this room complaining about the parking or complaining about the lane, but we're talking about a 2% reduction in access generally. Like, so I think including the cars has value in that it is demonstrating that the people who are loudest are not actually the people who are losing the most access.
Thank you. Yeah. And I actually wanted to bring in our co-speaker for this session to weigh in on this very question because of the focus on demand response transportation. So I'll introduce Steve Yaffe, and if you're able to highlight him. So Steve of Yaffe Mobility Consulting, he oversees planning and operations for Arlington County's local fixed route and demands response transit. He has prior fixed route experience with RT Metro in Sacramento and Houston Metro, as well as demand response experience overseeing WMATA's Metro Access Service and planning for FastTran, which is Fairfax County's consolidated human service transportation provider. There's a lot of information here about how much involved Steve is with TRB's international conferences on demand responsive transportation, and he's also a member of the Fairfax Area Long-Term Care Coordinating Council and the board of Independence Center of Northern Virginia. So, there is Steve. Can we hear you?
I actually am a independent consultant now and a contractor for Easter Seals for the National Aging and Disability Transportation Center, NADTC.org. I put in a little commercial in the chat. So glad to join you. This is very interesting. There's a lot of work going on with the Delaware Valley Regional Planning Commission and the Transit Center. And you can do so much if you move towards aggregated census block data for the American Community Survey. You can get a little more granular as to the type of neighborhood in each census tract, upper income, lower income, industrial warehousing, and all that, to see if people can get from lower income neighborhoods or minority neighborhoods to healthcare or outlying industrial warehousing. And then the next question is, okay, they can get to there by transit or by bike, doing it separately by mode. Is the travel time reasonable and comparable to other neighborhoods? That was Delaware's approach. There's a lot going on in this field. The main deficit is the database available in that some cities have sidewalk networks mapped out, some not so well. There's 4 or 5 new initiatives they talked about at TRB annual meeting this past January on different techniques to do that, including using aerial photo, which is quite exciting. And then the data for cycling networks is usually probably better because there's so much investment in that, but the lack of investment means they don't connect. But anyway, glad to join you. And did you want, now we had talked about questions and my responses.
Yeah, that would be great. So do you want to read out the questions as well, or you want me to question?
Oh, I can.
Okay.
In your experience working with municipalities and agencies, what are the important questions that these institutions want to be able to answer pertaining to any of the following: active transport, accessible transport, walkability, access to goods and services? And again, I need to emphasize I'm a bus guy, but I'm a road cyclist and I walk. Decision makers generally want to know both the number of potential trips and the unduplicated number of potential trip makers. And these should be segregated by demographic. For example, how many people cannot drive due to a disability or due to affordability or choose not to drive? How many folks are younger adults with disabilities versus older adults versus low income? And coming from Arlington, quite a population of those who prioritize environmentally sustainable travel or exercise. They may want to know how often would they travel for work, school, healthcare, that sort of thing. When presenting this data, always include gripping anecdotes focused on sought economic opportunity, for example, or safety. And our motto in transit is safety is number one. So that's the first set of my response. The second is, does network connectivity, I'm hitting that term again, enable them to walk, bike, or use transit to reach their destinations? And again, those destinations is not just the central business district, but it's post-secondary education, job training, jobs, healthcare, social service, and grocery pharmacies. And you have to really address these networks individually. We have already mentioned pathways, including accessibility information, which from aerial photographs is going to be hard to assess. So crowdsourced data, so important. I think it was first done in a suburb of Osaka, Japan, called Suisun City. Great presentation over 20 years ago at TRB on it, where everybody had disposable cameras. This was pre-cell phone. And they took a picture of every obstacle from their planned community into the center of this area, Suisun City, and into that train station. Because you don't know the obstacles unless you crowdsource it. You can't always tell it from data. Transit network, and the network is multimodal. We are moving fast towards focusing fixed routes on connecting each one a variety of land uses that are higher intensity, connecting lower income neighborhoods, where yuppie, I don't know, is yuppie still a term? Yuppie housing, commercial, office, that sort of thing. Every 15 minutes or better, all day, 18 hours a day, every day. But about lower density areas, they may still justify a fixed route with minimal frequency. And what's minimal? 30 minutes or better. And then you'll have transit hubs where demand response systems and bike share, and for those much younger than me, micro mobility, those scooter thingies, can connect and do transfers. And if you do it right with demand response, it's time transfers to and from fixed route. The next set, what is the cost? And I'm going to hit cost a lot. To create or improve network connections, finish that bike network and connect it up, operate and maintain those network connections, A lot of politicians have champagne bottleitis where they're glad to build it new, and then when it comes to maintenance, you can't find them. And subsidize each trip on these connections. So once new and active transportation are prioritized, the staging process can begin. And let me focus on cycle paths. Can priority expenditures on bikeways be reduced by co-scheduling with roadway, parks, or floodplain projects? Big strategy in Charlotte to do that. Can you fund it locally? If you get federal and state funding, that's wonderful, but what consequent environmental and other reviews are necessary before you draw those funds? And will that process interfere with co-scheduling with street repaving, for example? And then calculating the economic benefit of those investments, especially for active transport, well, cycle paths. Can you split it into increased property and sales tax revenues separately from folks who are now able to get to a job and their income, increased income? And what is the estimated ROI, return on investment, and how many years is required to achieve that full ROI? Key data for any government decision makers. And what do they use that information for? Well, the budget process is kind of split. Keep in mind that transportation as a whole has to compete against education, fire, police, and emergency management services, other infrastructure, especially sewer and water, personnel costs, and social welfare programs. So the first issue is slicing the pie. And then second is within your slice, transportation sector, you've got to compete against traffic safety improvements, road maintenance, and road capacity improvements, which are either to relieve congestion or to serve new developments. And so you've got to summarize all these budget developments, budget commitments, and weigh it against projected tax revenues with the current tax rate and the likelihood of increasing tax revenue through higher assessments of new tax sources. It's a real balancing act. And it gets even harder when it's time to reassess property taxes. So a lot on finances. Now to jump into data. Have I seen institutions be successful in integrating data from different modes to answer these questions for connectivity? Because remember, we're going towards intermodal, multi-provider linked trips, which could be bike share to a 30-minute route to a frequent route, and then walking. Oh, and what are the challenges of data integration, even in one region, or to do it to scale? So there we get into the weeds of how you format the data. Do you have consistent data formats? Do you have dependable and consistent strategies to gather and record information? It's very important. Especially, I mean, I could dive in just on your recording information and how you maintain your infrastructure. It all has to be in a consistent database, consistent manner. Equipment-based methodologies require regular validation to ensure that the equipment is functioning accurately. A good example I heard about at a transit conference last week was the information from electronic registering bus fare boxes. They have to compare it periodically on a trip basis with data from your automated passenger counters, usually the infrared counters waist high, and with manual counts by a ride checker. So you can figure out an expansion or contraction factor depending on your data source that gets you accurate results, because some data sources tend to, especially Farebox, tends to undercount. Do the counts from this data source, from the cords across bike paths, do the data counts from cords across bike paths compare for an hour with human observation? The main jurisdictional challenge for data integration concerns inventory and maintenance. Arlington, where I worked until 2018, has, I must have shipped you an old bio, I apologize, has one software database for all of their inventory: roadway, sewer, water, transit, everything, with GPS coordinates, data installation, expected component life. This is something that Norfolk Southern has never thought to do, apparently. Current condition, excellent, good, poor, or unusable, and maintenance data, what was done when. We've got, and why do you do all this? To maintain a state of good repair. You maintain the service on a cloud and get to it with a cellular enabled tablet and use pictures. But to do all this, you need commitment from your department and section leaders, training, review training, and a periodic check of your personnel on the street to ensure compliance. I was also asked to talk about partnerships. Nothing, in my view, nothing permanent and successful gets done without partnerships. And one thing that idea is being pushed at ITE, I'm glad to see, is get out of the silo, talk with folks who don't do what you do for a living. I've always worked with public health in every job I've had. For example, I worked with older adults, agencies on aging, centers for independent living, served on the board of one. You don't, as Rumsfeld said, you don't know what you don't know. And my response is, you sure as hell can find out. So I hope I've fulfilled your expectations in a quick run through.
Thank you, Steve. I guess my big question is, you've brought up some really important thorny points in how that data integration might happen. And Taylor, on the other hand, just brute forced his way through the connectome. And what are some ways we can connect those two stances? Because at this point, it's not really practical to expect that everybody would have the level of integrity of data that you just mentioned. What's feasible and what's scalable in the near future?
There are ways with APIs to convert data from one format to another. For example, demand response, where I do most of my work, you've got healthcare sending in managed care organizations are buying rides, just cheaper than wasting equipment time and staff time on somebody who doesn't show up. So they will go to an aggregator. I need so-and-so transported at this time to this place. They'll send it in turn to a ride provider who does that trip. They all may have different software formats, but they're tracking those rides through all those different software formats so that they know the person's on the way and is going to show up at such and such a time. Otherwise, the ride provider doesn't get paid. So there's techniques to do that. I hope that helped. As far as your inventory, that's not a practical solution. There's too many different systems to maintain. Conversion is painful. It takes a few years of planning and structuring and training and focus groups with the people who do the work. But it can be done, and several cities have done that. But it's a lot of effort and requires commitment from the top. That help?
Yeah, I mean, the advantage of doing what I've been doing in a research setting is you don't actually have to work with the city yet. But I do think that this kind of data integration question is really important. It's probably one of the main things we're all here to talk about this weekend. And that's why I think it's so exciting, the work that Annette's doing on open sidewalks, the work that people like Cyrus are doing on promoting data standards at the national level, and having Maggie here yesterday talking about international OpenStreetMap data standards. I mean, that's great. I don't know what that might be for demand responsive transit, but I'm sure there are smart people in this room and other rooms figuring it out.
We have 3 different efforts going on that. The mobility data folks, Vancouver, I think, are leading the GOFS effort, GOFS, to come up with a GTFS real-time equivalent for demand response. It's not, they're getting there. It's not going to be this year. I don't know if it'll be 2024. I hope so. And there's a separate effort being led by SUMSI and AARP for transactional data standards out of TCRP report 210, so that we can exchange data on an easy to track basis with protocols.
Any questions from the audience? All right. Well, thank you, Steve, and thank you, Taylor, for joining us today and telling us all about these efforts. I like to hear the 2 ends of the spectrum and then trying to meld them together. We appreciate you joining us. Please join me in thanking both of our speakers.